So for this problem, we have 5x increased by 120%. I want to show you two different ways to do this. The first way is more of a conceptual understanding. So if we have 100% of something, and we're increasing it by 120%, so another 100%, another 20%, then what percentage is that total now? Okay, because it's not just 100%, right? We increased it. And where students kind of confuse this is they think, okay, it's increased by 120%, so that means it must need 20% more. But it's not just 20% more, it's 120% more than what it already is. So conceptual kind of understanding is that you now have, if you increase by 120%, 220%. And to find out what that total value is going to be, you're going to take 220% of that that product they give you, so 5x. And then 220%, remember, that's a description, it's not a number. So we want to change that to a decimal. So we're going to bring over the decimal point 2 spots. So we get 2.2 times 5x. And when you do 2.2 times 5x, you get 11x. The other way to think about it is, let me just erase that real quick. Is to think of it in two different pieces. So 100% would be 5x, right? I start with my value, and increase by means I'm adding, so increasing it by something. And when we say 120%, the question always comes up, 120% of what, right? Well, the subject in this is 5x. Okay, so it's 120% of 5x. So it's 5x plus 120% of 5x. And again, 120%, that is a description, right? So we want to change that into a number, which would be 1.2. So now we have 5x plus 1.2 times 5x. And then 1.2 times 5x is going to be 6x. So we have 5x plus 6x. And then when you combine your like terms there, you get 11x as your final answer. So those are two different ways to do it. This one's a little bit more algebraic. The other one's a little bit more conceptual. Either way, either way you think about it, you're going to be set up for success. For this one, they're asking the length of 2/3 of a rope is 4u minus 5 inches. Okay, so we have an expression for 2/3 of a rope. Express the total length of the rope in terms of u. I think the easiest way to do this problem is to actually make a rope. So we're going to draw a little bar model of a rope. And this rope is split into 3 pieces, right? It says 2/3 of a rope, so we're going to split it up into 3 pieces. And I know that of those 3 pieces, 2/3 of them are 4u minus 5. Now, when I broke up this rope into 3 separate pieces, okay, they were 3 equal pieces, right? A third, and a third to make 3/3, which is 1 whole rope. The 4u minus 5, this expression represents this piece and this piece right here. And when I look at both of those pieces, I know that they are equal to each other. So what I'm trying to figure out is what this piece is, because I want the length of the whole thing, not just 4u minus 5. So I need to find this part here. So if I know that these two are equal to each other, then what I can do is, I have two equal groups. I'm going to split up 4u minus 5 into two equal groups, and I do that by division. So I'm going to take half of 4u minus 5. And when I distribute in, 1/2 times 4u is 2u. 1/2 times negative 5 is negative 2.5. So that's going to give me each little section. So this section is 2u minus 2.5. This is 2u minus 2.5. And in the beginning, I broke it up into 3 equal parts. So that means that this should be equal to this, should be equal to this. So this one is also 2u minus 2.5. So what you can do now is you can either add all of these together, or you can take what you got when you split them up and found the individual piece and multiply that by 3. I think that's easiest to do. So we distribute in 3. 3 times 2u is 6u. 3 times a negative 2.5 is negative 7.5. So the final answer for this one would be the rope is 6u minus 7.5 inches long. This one asks, if 50 pounds is equal to 22.68 kilograms, then what is 15/8 y pounds in kilograms? So sometimes it's helpful, if you have this kind of confusing number here, 15/8 y, to not think about that as as this unknown. Let's give it a number. Let's say it's 10. And let's reread the problem. Now we're trying to find if 50 pounds equals 22.68 kilograms, what is 10 pounds in kilograms? Now it's a little bit easier to understand. Okay, so if you want to figure out what 10 pounds in kilograms is, there's one thing you need to know first, and that's how many are 1 pound, right? How many kilograms are in 1 pound? So let's think about this. Let's say I have a 50-pound weight here. Okay, this whole thing weighs 50 pounds. And I want to figure out what 1 pound is. So let's pretend that I'm just breaking it up, right, into these little 1 pound pieces. And each of these pieces are going to be equal to each other. So if this whole thing is not only 50 pounds, but it's 22.68 kilograms, this little piece here isn't just one part of 50, it's also one part of these whole 22.68 kilograms. And to figure out how many are there, well, I have 50 pieces that I broke it up into. I didn't really use 50, but I just kind of estimated so you could see the 1. But it's broken up into 50 pieces to get 1 pound. So to figure out how much 1 pound is, you're going to divide this by 50. And that gives you that's your conversion rate. So we call it. So 1 pound is approximately, and I'm just going to write it as 22.68 divided by 50 kilograms. And we're not done yet, because we know what 1 pound is. But the question is, what is 10 pounds in kilograms? So if I know what 1 pound is, then to figure out what 10 pounds is, I would just take that value and I multiply it by 10, right? Because I have 10 of them. In this scenario, though, I was switching 10 out for an unknown. So let's bring back the unknown. So now I have 15/8 y pounds, but I'm going to use the same process. Okay, instead of multiplying this by 10 to get to 10 pounds, I'm going to multiply 22.68 over 50, that's my conversion rate, times 15/8 y. And normally we don't like to have a decimal inside of a fraction. That's called a complex fraction. So we could change this here to 2,268 over 5,000, which eventually you can reduce. And to find that final answer, what you're going to do is you're going to multiply across. You can cross reduce, of course. Okay. And then your final answer is going to be, as a decimal, it would be 0.8505 kilograms. So for this one, I'm asked to write an algebraic expression for the perimeter of the quadrilateral shown. And I'm given all four side lengths of this quadrilateral. And when I find the perimeter of quadrilateral, I'm just adding up the pieces. So let's write that out. I'll start with 5/4. That's this piece here. So we have 5/4 plus 4/5 w plus 1 plus 5w plus 13/8 and finally plus 8/5 w minus 1/2. And let's make sure that I got all sides there. So that one, that one, that one's there, and last but not least. All right, excellent. So I've got all four side lengths shown. And I'm not done, right? I want to keep going all the way till I've simplified this problem all the way down. So I want to combine my like terms. My terms here are going to be terms that have the variable w and terms that don't have the variable w, because that's all C that I'm working with. So let's go ahead, circle and square those in different colors. So I have 5/4, and when I find other numbers, other terms that don't have variables, when I circle them so I know to combine them, I'm going to take the sign to the left. And you're going to do this in such a way that everything that's circled or squared in, that you're not going to have any gaps in this problem, because if you have a gap, it means you're leaving out information. Okay, so as a way to make sure you're not leaving out information, you're going to circle with the sign to the left because it shows what kind of number it is. So that's a positive 1. This is a positive 13/8. This is a negative 1/2. And then in red, I'll do my W, so 4/5 W. 5W, positive 5W. Positive 8/5 W. And all I'm going to do now is I'm going to combine those separately. So first I'll do my regular numbers. I did that in blue, so I'll use the color blue. And I've got 5/4 plus 1 plus 13/8 minus 1/2. And I know I need a common denominator when I'm using fractions, so that common denominator looks like it's going to be 8. So this becomes 10/8 plus 8/8 plus 13/8 minus 4/8. And then I can combine these. So out of the eighths, I have 10 here and 8 here, so I have 18/8. Another 13/8 would give me 31/8. And then I'm taking 4/8 away. So I'm taking 4/8 away from 31/8, which leaves me 27/8. And then separately, I'll combine my terms that have a W. So that's 4/5 W plus 5W plus 8/5 W. And again, these all have fractions, so I'm going to find a common denominator. When you have a whole number, technically the denominator is 1. So it looks like the common denominator is going to be 5. So this is 4/5 W. This becomes 25/5 W. And this stays 8/5 W. And when I add all those up, I get 4 plus 25 is 29, plus 8 is 37. So I have 37/5 W. So my final answer is when I group those two together. So when it says write an algebraic expression for the perimeter of the quadrilateral shown, I'm going to say it's 37/5 W plus 27/8. And we're using feet. A ribbon measuring V plus 4 feet in length was cut into 2 pieces in the ratio of 3:7. What was the length of the longer piece? So a couple of keywords in here. It says a ribbon measuring V plus 4 feet in length. That means we're talking about the whole ribbon. And ratio means separate pieces. So we are going to have different pieces, right? 2 different pieces, but we also want to think about the whole. So let's start with just kind of labeling. We'll say this is the short piece, the longer piece, and the total. So if the short piece was a ratio of 3, the longer piece had a ratio of 7, that means in total there were 10 pieces. And if I look at that ribbon, if I were to make it, then I would break it up into 10 pieces. And if I were to fill those in, the shorter piece would have 1, 2, 3 parts, and the longer 1, 2, 3, 4, 5, 6, and 7. And this whole thing here is represented by V plus 4 feet. And what's asking me is what is the length of the longer piece? So I'm going to figure out just this blue part here. And as a fraction, we know when we talk about fractions, it's always part over the whole. So when we have the part over the whole, let's look at the part. Well, the part of the longer piece is 7. The whole of this whole ribbon is 10 parts. So that longer piece is 7/10, right? Takes up 7/10. And we're now going to bring in the fact that the whole rope is V plus 4 feet in length. So this longer piece portion is going to be 7/10 of the length, v plus 4, and that's in feet. So this is one of the harder problems to kind of conceptualize. It says when 1/5 of the boys left, there were still B boys and G girls who stayed to see a program. What was the total number of boys and girls at the beginning of the program? So when you kind of think about it at first, it looks like if 1/5 of them left and there were B boys still there, then it would have been 6/5 of the boys in the beginning. But that's not the way that the variable B is broken down. And let me show you that. It's easiest to show that with a bar model. So we're going to let this bar model represent the boys, and this bar model can represent the girls. And it says in the beginning 1/5 of the boys left. So let me break that up into 5 pieces. And that's 5 equal pieces. And nothing really happened in this situation with the girls, so I'm going to leave that bar blank. Let's focus on this bar that represents the boys. It says 1/5 of them left. So let me shade in 1/5 of that in red, and we'll label that boys that left. So all the other parts then would represent the boys that stayed. Right? So these blue pieces are the boys that stayed. And that's the variable B. So B boys that stayed. And here's the tricky part. We have to figure out what this is. How do I represent that either with the variable B or the variable G so I can give an expression for how many boys and girls there were in the beginning of the program? Because it looks like it's 1/5, right? It's 1/5 of the total, but I don't have a variable that represents the total. I only have a variable that represents the people that are remaining after the 1/5 of boys left. So what do you notice about this red piece compared to these 4 green pieces? And you should see right away that they're all in equal length, right? Because I split this up into fifths. So that means this is an equal part of these, right? So red is going to be an equal part of each of these blue pieces. So while it is true that that red does mean or stand for 1/5 of the total amount of boys, in terms of the variable B, if we want to put things into B, right, because that's the variable that we're going to use, it's the only one we have, then it's the same as 1/4 of B, because B is broken down into 1, 2, 3, 4 parts. And so when I put this all together, I have the 1/4 of B that represents the boys that left. I've got the 4/4 of B that represents the boys that stayed. And then I have G, which represents the girls. And when I combine like terms, I have 1/4 B and then a positive 4/4 B. When I add those together, I get 5/4 B plus G. And that would be the total number remaining. So this one's tricky because you have to figure out what that 1/5 represents, and you have to figure out in terms of B. And to do that, you have to know what B is. So it's a little bit of conceptually challenging. But if you break it down this part, it's easy to see that B represents the remaining pieces in that fraction bar. And each of pieces in that fraction bar is 1/4 of B, yet it's 1/5 of the total amount of boys. But that's interchangeable in the amount size.